Hey guys, welcome to our fourth installment of ScaleFlux webinar. We're really excited that you could join us today. We are fresh back from FMS, where we were talking about our latest CSD product family release, and most importantly, how we've evolved from a organization that would essentially put together various components, Xilinx FPGA, various flash types, to actually developing our own SoC. So excited. Thank you for joining us.
Yeah, thanks.
So JB, at the show, we were getting a ton of questions. The one I think we should lead off with is, who is ScaleFlux?
Yeah, that's because we're not a super well-known name in the industry. ScaleFlux is a revenue stage startup. We were founded back in 2014 by a group of storage industry, and database technology veterans. And they all kind of came together with that same vision and saw that innovation was needed in the storage and memory domains to help meet all the demands of our data-centric environment that we live in. And so they put together the company. They started pulling in talent from leaders in the industry and launched the first generation of product back in 2018. Launched the second generation of product in 2020 with some new features and a pivot. Yep. And now here in 2022, we're launching that third gen, which, as you mentioned, is that transition point from using an FPGA, which allows for that rapid prototyping, yep, to a custom-built system-on-chip processor that allows us to improve performance and power performance and add more features into this product and make it very, very competitive in the NVMe market space.
Outstanding. So, second number one question we get, how fast are we?
Yeah, so in the 3000 series, it's a PCIe Gen 4 NVMe SSD. And with that, we get up to 7 gigabytes per second on the sequential reads. And we throw out a lot of these numbers, sure, and people don't know what they mean or how to put them in perspective. So something just to kind of put that in perspective is that your high quality video stream from Amazon is going to burn about 25 megabits per second, not gigabytes. And so a single drive from us can deliver over 2,000 4K video streams concurrently. Wow. So just to kind of put that 7 gigabytes per second into perspective. But the performance question is sort of a trap.
I agree. It's really a hero number that a lot of our competitors, as well as other NVMe vendors in the space, put out. So what's like a 50-50 read-write workload? Where do we shine there?
Yeah, so we definitely outshine the competitors in any kind of mixed workload. Okay. We'll go into that a little more detail there, but something else with the performance is that we all tend to talk about these four corners sure, performance hero numbers. 7 gigabytes per second sequential reads, 4 or 5 gigabytes per second on sequential writes. 1.5 million on random reads and 300,000 on random writes, but that's not super important in the real world.
They're synthetic, right, benchmarks.
Yeah, it's these mixed performance numbers, latency, consistency that become much more important.
Got it. So with that being said, what really kind of differentiates us from our competitors?
Yeah, so it's exactly what happens in between those four corners. So at the full sequential read or full random read, everybody's kind of saturating the PCIe bus. That becomes the bottleneck. But what happens when you start to mix writes into the workload? Say 10% of the workload is writes, or 20 or 30 or 40%. Well, every drive out there, and this has been over the generations of SSDs, it's just a fact for SSDs, that as soon as you move off of that 100% random read workload, and mix in writes, the performance drops dramatically.
Absolutely. The write cliff.
The write cliff that Eric talked about in one of the prior webinars.
Oh, that's right. Could we get a link to that for those who are just joining this first webinar today?
Yeah. And so everybody suffers that penalty, but with ScaleFlux, what we've done is integrate some innovations into our drive that allow us to mitigate that penalty. And so what you'll see is that even as we mix in writes to, yep, the workload, our performance remains very, very high. And in that typical area where transactional databases are going to live, where it's anywhere from 90 90-10 read-write to a 70-30 read-write workload, we're up twice the performance of ordinary drives, ordinary NVMe SSD drives from the leaders out there. And if you go all the way to the 100% random write, that's where we're up to 4 times the performance.
Absolutely. So with that being said, how does the compression work? Is it a post-process? Is it inline? Tell me about more of the transparent compression capabilities and how it's done.
Yeah, I mean, so the transparent compression, that's the innovation that we put in there to deliver that massive boost in performance. And I'll try to keep it simple.
Yeah, high level, please, high level.
But there's 2 parts of it. One, we are compressing on small chunks. So for every 4 kilobyte chunk of data that comes in, we compress that. We find repeated patterns. We find 0 padding in there and eliminate that to reduce how much data has to get written to the flash.
Got it.
And then the second part of that, this is the real magic and challenge, is that we had to make innovations in our flash mapping. So every SSD has a translation from where that logical block of data that the host sees is and where it's physically located on the NAND.
Got it.
Okay, but in addition to marking where it is on the NAND, our flash translation layer takes or understands how big the data was when it was put out there. So we keep track of both where it is and how much space it took on the back end.
So with that being said, how does compression impact latency? Is this something that takes host side resources? What exactly is involved with that?
Yeah, so usually, or traditionally, compression, when you turn it on, it increases your latency and makes your application performance worse. And that's the reason that is because you're putting it onto the CPU.
Right.
And it's a very CPU hungry task, but it's a fixed algorithm. So that makes it a great candidate to put into a hardware engine.
Sure.
And when you do things in a hardware engine with a fixed algorithm, it is lightning fast with minimal latency and eliminates putting all that pressure onto the CPUs.
Absolutely, just simply offloads it to our drive.
Yeah, and so counterintuitively, doing compression in the drive actually results in lower latency, better latency consistency, and elimination or reduction of those outliers in latency.
Sure.
Where you talk to and I talk to a bunch of customers, and what they really, really care about isn't necessarily those hero numbers we talked about,
sure.
the 100% random read, 100% random write type numbers. What they care about is how fast and how responsive is my application always. My user doesn't want to have the experience of an outlier on latency, because then they're calling the operations people saying, why is my application operating so slow?
Sure. And since we're compressing data, we're actually writing less data, which means we're reading less data and ultimately making those drives last longer as well.
Yeah, that's kind of how it reduces the latency is that there's kind of 2 orders of effect on this. So we compress the data, and so we write less up front, which makes it easier on the drive. And then when we read, each read has a higher payload of data. Because if I grab 4K of data off of the drive,
sure.
Now it's going to expand to 8 or 16K of data to deliver back to the host.
Yep. Got it.
And then kind of the second order is that as I write, each die in the NAND can either be writing or reading. Right? We can't do both things at the same time.
Absolutely, and that's where alternative NVMe drives generally experience that write cliff, where we actually have more of a sustained read-write performance. Yep. Awesome. So with that being said, we did announce 2 different product types. We do have the NSD and the CSD. A lot of my customers ask, well, which one is right for me? A lot of our channel partners that we work with are, also wondering, hey, what one should we potentially position for their customer? What one is right for them?
I don't know. I've trained you. Why don't you tell us?
Got it. Well, that's fair. So we made the NSD specifically for applications where there could be some interoperability where the application or database isn't as compressible. So that's where the NSD really shines. It gives you 2x performance and also the endurance of the capacity gains that you would normally accrue with CSD, but no real alteration to the application or host. The CSD is really going to give you 2x the performance, 2x the capacity, and 2x the endurance. So really it's where you can actually have a little bit more engagement with the actual application, ultimately giving you 2x the capacity.
Yeah, I mean, it's the, try to shorten up a little bit. The NSD is that easy button for performance, latency, and, excuse me, and endurance improvements. And then the CSD is you want to get a little more advanced and leverage the transparent compression to get additional capacity out of your drive as well.
Fair enough, absolutely. So let's get to the nuts and bolts of it. What does an 8 terabyte drive cost these days? So,
yeah, I mean, out in the marketplace, 4 terabyte drives are on the order of $1,000, and 8 terabyte drives are on the order of $1,800. These are kind of unit one pricing on the internet. Prices we mention here are examples.
Sure.
The legalese, we're not quoting pricing.
Yep.
But in terms of actual pricing, I'm going to punt to the sales guys because marketing doesn't do that.
That's fair, and thank you for doing that because we actually enjoy having that discussion with the customers. Most importantly, our 4 terabyte drive, again, with our CSD product family, will give you actually 8 terabytes of usable capacity. And our street price for those drives, actually list price is $1,300. So again, I'm positioning a 4 terabyte drive, which subsequently gives an end user customer 8 terabytes of usable capacity.
Okay, so that your original question of what's it cost me to get 8 terabytes of capacity, well, it's about 30% less, 40% less than it would be with any other.
Absolutely, at 2x the performance, 2x the capacity, if you're looking at a 4 terabyte drive originally, and then most importantly, a longer lasting drive.
Cool.
With that being said, what does a customer have to do to capitalize on our transparent compression capabilities with the CSD 3000?
Plug in the drive.
Awesome.
That's all you got to do.
We've been waiting for that for a long time, so we're so happy it's here. Again, it's pretty ecstatic with the sales team, the fact that we don't have any proprietary drivers, full 100% NVMe standards, and most importantly, it just plugs right in.
Yeah, I mean, we've had, I kind of joke there, but we've had so many calls with customers, and this question does come up all the time.
Yep.
With, do I have to install any software? Do I have to install any drivers? Is there anything custom with this? And no, we're leveraging the in-box NVMe drivers, so we can support Linux environments, Windows environments, VMware environments. It just uses the in-box driver on those. There's nothing that you have to do special to use our drives instead of an ordinary NVMe SSD.
Awesome. And I guess that kind of jumps into that same question you just answered. But do you have to modify your application at all?
Yeah, and yeah, we get this all the time too. So here again, no, there's no application modifications. We're selling the whole thing of that transparent compression is that you don't have to know that it's happening. Your application doesn't have to know that it's happening. It just happens in the drive. You don't have to trigger it. Just every write that gets sent to the drive, we're going to compress the data. Sure. Every time you read, we're going to decompress it. And so you get all the performance, endurance, latency improvements without any modification to your application. So, this isn't a buy it and allocate resources to figure out how you're going to use it, or sure, do a project to reconfigure or recompile your application. Plug and play.
Awesome.
Now, with the extended capacity, you do have to monitor the capacity.
Absolutely. Just as you would with any other NVMe drive, right? You can't overwrite to a NVMe drive.
And so, but users are going to use standard server monitoring tools like a Nagios or a Prometheus, and we have plugins for those.
Yep.
And if we don't have a plugin for your application, let us know, and we can work with you on that.
Last but not least, you said this saves me money. How exactly does this save me money other than just the capacity gains that we're talking about here?
Yeah, this is the part where each individual is going to see it a little bit differently. But offloading the compression to the drive can have tremendous second order and third order impacts on the cost of your infrastructure.
Got it. So
okay?
Software licensing,
yeah,
power,
yeah,
cooling. are all locations where a customer is going to be able to capitalize on.
Yeah, because if you look at this and like we've done testing with many different applications. We have customers using MySQL with AeroSpike, with RocksDB,
Kafka.
many other Kafka, many other applications. And I'm going to generalize here, kind of across the board. What they see is somewhere 1.5 to 2.5 times the performance per server for their application.
Sure, simply because we're offloading I/O that would normally be done at the host to our drives.
Yeah.
That's awesome.
And so, you think about that, and if you have a fixed amount of work you need done, well, you can do it with half as many servers. Or if you're starting to run out of space in your rack or your row or your data center that you've leased, you can scale to twice as much performance, twice as much work before you have to buy that next increment.
Yep.
And then, as I mentioned earlier, that the compression is a very CPU intensive task.
Absolutely.
And so offloading it to our drives, we can do the same level of compression throughput as over 100 Xeon cores. And if you're talking, you mentioned the software licenses, so
Sure.
applications like SQL Server or Oracle Database,
Right.
where you're paying thousands or tens of thousands of dollars per core that you use, because they're core-based licensing. Now, why would you want to use cores that you're paying those expensive licenses on to do compression?
Agreed.
Right? Transfer that to the drives, free up those cores, get more work done, get more work per software license, or potentially significantly slash the cost of your licensing.
Sure. Outstanding. Thank you for that. Those are some of the questions that were asked of us at FMS. Were there any that were in the chat that we could answer live? I can't read that first one. You see it up there, JB? Let's see. Does it support VMware? Yes, we support VMware out of the gate. That is a TAM that we are excited to be going after. Also, does it support Windows? Yes. Previously, we were only Linux supportive, but now we have significantly opened our TAM to those alternative locations. Let's see, and then last but not least, our next event will be at OCP in a couple weeks. Looking forward to talking with our partners, end users, as well as any other techies that are going to be at the show.
Yeah, let's see, what else? Okay, so we've got, what if I already compress my data? That's great. Yeah, we get asked that quite a bit because there's a lot of applications that do compression by default.
Sure.
So there's two things there. One, turn off that compression by default because you're burning your CPUs for a task that can be done much more efficiently, much faster down in the drive. And two, even if you're doing compression at the host, we're still finding that in many cases, like if you've done LZ4 compression, there's still about 20% compressibility left in that data.
Yep.
And then I mentioned the SQL Server. It does some row and column compression, but then it'll pad with zeros to get to a full block.
Yes.
And so we can then take advantage of that to achieve some additional compression. So, if you're already doing compression at the host, then the NSD is probably going to be your choice.
Absolutely.
Because you'll still get that little bit of compression that'll get you that twice performance, better latency, and twice the endurance.
Yep, great.
Let's see, there was another, the detail on compression, is it lossy or lossless? Yeah, so unlike some of the video or audio codecs where you're doing lossy compression just to reduce the data stream and you're willing to sacrifice some quality, we can't do that in the enterprise data. I mean, that would be ridiculous. So no, this is lossless compression. We're using standard industry algorithms, a Z standard algorithm for our compression.
Great. And then I do see what capacities are available. Again, today we have 4 terabyte CSD and an 8 terabyte NSD. We will have larger capacities coming in the next coming months, but that's what we have launched and are currently shipping with the CSE or CSD product family.
And then where can I get drives? Well, you can get it from Sterling.
Yeah, you could email me directly, or I think our company would rather have you email info@scaleflux.com. But you can always reach out to me as well. I'd be happy to connect you to Sterling at ScaleFlux.
Yeah, and then on our website, scaleflux.com, There's also a contact us button, so you can fill out a quick form there and request samples, request more information. You can click over to our partners pages, because we did recently announce our channel partner program.
Absolutely. We have Cynix lined up as our distributor here in North America, and also hyperscalers internationally. But look forward to working with partners, as again, we can only sell so much directly. We really are happy to onboard more partners as we take this product to market.
Did we have any other questions? All right, well, shoot us a note if
Thank you,
have
guys.
questions afterwards.